Here we are on Jacques-Charles law. So Jacques-Charles, using kinetic molecular theory as his guide, discovered that if pressure and the number of particles in a system are constant, there's a direct relationship or a linear relationship between volume and temperature. So here's the formula. Initial volume divided by initial temperature is going to be equal and proportional to final volume divided by final temperature. And it's important to note here that those temperatures must be in kelvins, and we'll use that in the example. So V1 over T1 equals V2 over T2 is going to be Charles' law. Take a moment and we'll move on, write this down, and we'll move on to the next slide. So if we graph Charles' law, you'll find that volume is on the y, temperature is on the x, and that the slope is going to be volume divided by temperature. That is going to be your proportionality constant k. So dividing v by t, you get a proportionality constant k, and the graph is linear. And here we go. We're going to give this a go and do this example. If you have 45 liters or 45 decimeters cubed of helium in a balloon that's 25 degrees Celsius and increase the temperature of the balloon to 55 degrees Celsius, what will be the new volume of the balloon? And I gave you the hint that we must convert to kelvins first. So here we go. What I'm going to do here is I'm going to set up Charles' law. I know I've got initial volume divided by initial temperature divided by final volume and final temperature. And my goal is to find the new volume. So I'm going to isolate V2. To do that, I multiply both sides by T2. Boom, boom. So I'll get this expression equaling V2. Now, really important piece here. I've got to change these temperatures to kelvins. And that's because they go up proportionally by 273 degrees for every change. So it's important to make sure that I'm in kelvins to represent that change. So I'm going to say 250 plus 273 gets me 523 kelvins. And that's going to be my T1. So 523. My initial volume was 45. And then my T2 is 550. So 550 plus the 273. It's going to get me 823. So multiplying the 823 kelvins times the 45 liters, all divided by 523, should get me my new volume. 823 times 45, get that. With 2 sig figs with that, it's going to be 37,000. Here comes those sig figs again, divided by 523. 37,000 divided by 523 gets me a new volume of 71 cubic decimeters. Rounded to 2 sig figs because I had to round to 2 sig figs because my initial volume here was 2 sig figs. So if I'm looking at this for my double check, I increased the temperature, so I should have increased the volume. My initial volume was 45. My final volume was 71. Or excuse me, 71. So that happened. So I am correct. At the bottom of this, there are some Charles' law problems for you to peruse and get comfortable with. Good luck.